you would use GCF? So the answer is kind of within the name here. GCF, you're looking for like every term has an X in it.
Mm-hmm.
Right. Now, in the case of letter D, it's 3x squared equals 12x. But when you move everything to one side, does every term have an X in it?
Yes.
Yes. Okay. And we'll get to solving that in a minute, but let's look at another one let's look at another possibility. What if it's 4x cubed plus 3x squared minus x equals 0? Is this GCF? Does every term have an X in it?
Yes.
It does. Now you would factor out an X in each of these, but let me show you, what does this produce now?
4x squared plus 3x minus 1 equals.
But what is this? Like what, like, do you have a name? Do you know a name for this? I'll give it to you if you're not sure.
Quadratic. I don't know.
Yeah, it's a quadratic. It's a trinomial. It's a quadratic. And the problem is that like the way this is written here in your notes is your GCF problem is probably just going to have two terms in it.
Mm-hmm.
So that's kind of another way to know that that is, because this one down here requires you to do something else like factoring. Now, let's see if they covered that. No. Okay, so your GCF problem will almost exclusively have two terms in it.
All right. So those two terms would be
whatever there. So we'll solve this one in a moment. But like, do you see though that if you factor an X out of each of these, you get like a quadratic trinomial that you then have to go back and be like, well, which one is it?
You can like get rid of some of the X in that.
Yes. But one of the ways you know it's a GCF is that every term has an X in it.
Every term has an X. Every term in GCF will have an X.
Yes, because you're going to factor something out.
Because you're going to factor something out. All right. Every term has in it. And it's so because it can factor out.
Yes.
All right.
Okay, so a little bit more information here. For a GCF, it can either be a number or a letter or a number and a letter.
Mm-hmm.
Okay. Now the ones you care about are these last two. That's what you're going to see. So in this example that we were looking at, what is the number and the letter that you can factor out of both of these?
3x.
3x, and that gives you x minus 4. Okay, you're feeling really good about that, and we can continue from there. But let's say I give you another one. Let's say I go 5x squared minus 3x cubed equals 0. Does each term have an x in it?
Yes, it does.
Yes, it does. So is this GCF?
Yes.
Yes. Now, what is common between both of them?
They both have x squared.
Yes. So now this becomes 5 minus 3x.
5 minus 6. So then
that's it. Like that's as far as I want us to go for the moment here. But is it okay that GCF every term has an x in it?
Yeah.
That's what you're looking for. Okay. All right. So now the next one that I think is the most easy to identify is a square root property.
Square root property.
All right. So here's an example of a square root property problem.
Uh-huh.
Okay. Can you maybe tell me in your own words why you think this is a square root property?
Because there's a squared in it, but then also it equals a number. So it
Okay.
doesn't equal 0.
Those are both true. Okay. So I would call that it's got an isolated square term.
Uh-huh.
And then, like you said, there's a number on the other side. But I want you to, there's another thing you can do here, and this is this will help a lot, is I'm gonna ask you, how many X's do you see?
I see 1x.
One X. So look at A, B, C, look at A, B, and D. So top left, and bottom right on that paper. Do you notice that in all the other problems, there's more than one X?
Sorry, say that one more time.
I'm going to snip it in so you can see. These are not square root properties, but I want you to see why. There's an X there, and there's an X there.
Okay.
So this is not square root property.
So then.
And then in B, kind of the same deal. See how there's more than one X?
Yeah. So then square root property. So is it because there's no parentheses?
That's also true, although that's not necessarily the total reason. But like, again, like, see how these have more than one X? But the one that worked, the one that's good in your paper, let's get the one that's good here. Let me snip that in. How many X's do you see here?
I see 1x.
So 1x. 1x means it's square root property.
Square root property.
But it's also the other stuff that we just mentioned, like it's in parentheses. It's the only one with a parentheses.
Uh-huh.
Okay.
So then parentheses, square root property. All right, I'm good on that.
Okay, so let's look at again. If I were to write 4x plus 2 squared minus 3 equals 6, why is this square root property?
It's square root property because there's an x, parentheses, and a squared.
Yes. Okay, now the following is also a square root property.
So
let's go, sorry. Why am I struggling here? 20, okay, there we go. So this is also a square root property. Why is that?
There's x squared, I guess.
Yep, that's true. There's only one X. There's only one X term also. That's another thing.
Oh, yeah, because x equals.
Yeah, so this is like a small variation on what we just, like the last one, but most likely you're going to see something in parentheses here.
So, okay. So you'll most commonly see it in parentheses.
Yes.
All right.
Okay, so let's do a little synthesis here. You tell me which property it is, or which one it is. It's just the two options here. We'll give you a couple of problems here.
All right.
Yeah, give me just a moment here. Get one more in here. Let's go. All right. What say you? Give me any of these jump out at you. And there's only two options here. It's either GCF or its square root property?
I see. I think the bottom one's GCF.
Okay, it is.
Top one's GCF.
Okay.
And then 2 and 3 are square root property.
Okay, I agree with that. Now this last one here, it's in a weird form. You can actually factor more out of this, like it's 5x minus 4. And then there's another x here also.
So then so when it's like that, would you just you'd make it x squared?
Yeah, because this x on the left, on the right here goes with the x you factored out on the left.
Then would that actually be a square?
Yes.
Okay. And then what's the difference if there's an x and also let alone an x squared in front of the parentheses like that?
No difference. When you solve it, you get the same answer, which we'll get to. We should probably do just a little more identification.
All right.
Unless you want to talk about how to solve GCF and then square root property problems.
I think I'd like to learn just how to solve them first, because that's what I'm having just a little bit of issues on right now.
Sure. Okay, so let's start with GCF. Let's talk about how to solve these. So let's say I give you a 2x squared minus 4x equals 0. What is the GCF in this? 2x, x minus 2 equals 0. So you set each term, and there are two terms here. And this is maybe what's hard, is this is a term, and this is a term. Set each term equal to 0.
So then, so it's always set to 0, right?
Yes, always. There's no exceptions ever.
And then you solve. Oh, right. 2x equals 0, x minus 2 equals 0. And then,
so these are both one-step equations. Now they could be two-step equations, but these are one-step equations. Like you just do one operation to get x, one operation to get x.
All right. And then,
so let's try another one.
You'd make a mark on that graph with a 0 and a 2.
Nope. I mean, you could do that, but this doesn't ask for any of that.
Yeah. I was just asking that because like I see that occasionally.
Yes. Okay, let's try another one here. Okay, let's try this one. So this is GCF again. Sorry.
Okay, so I guess x can take it out. So then that would become x squared minus 7 equals 0. And then x equals 0 and x squared minus 7 equals 0.
Yes.
And then
now this is already solved. There's nothing to do here, but this one is the type I think we're looking at the last time we met.
So then you can make that a plus 7. X equals 0 and x equals plus 7.
Well, you have to move the 7 to the other side of the equation. So it's x squared equals 7. Then how do you solve this? How do you solve it?
You have to do square root.
You square root both sides, and when you square root, it's plus or minus. So x is plus or minus square root of 7.
So then would you just literally write x equals minus 7 and x equals positive 7 and then x equals 0?
But you, okay, so what you said, here's what you said. But what is this symbol right here?
Square root.
Yes, so like your answer is the square root of 7 and minus square root of 7.
Okay.
Like I'm still hearing a little bit of like where you're not sure.
Not like confident with it.
Yeah, you don't know what to call it, and it like this is not friendly. Like it just is the square root of 7.
Okay, so like we don't have to do anything past that.
No.
Okay.
Yeah, like I know you want to like I know you want to like get a number,
Uh-huh.
but there is no get a number here.
All right. Yeah, I don't know. Just like problems like that, like I always just feel like uneasy with it first because
Yeah.
it's like it
So
feels
the answer is 0 square root of 7 minus square root of 7.
all right.
Okay, so let's do another here. So your GCF, and I mean I'm telling you, so that's helpful, but it's just so let's go 10x squared minus 30x cubed. It's a cubed.
So then you can divide that all by 10x, which then gives you
Squared.
x squared, my bad.
Yep.
Which then just gives you 1 minus 3x equals 0.
Okay.
And then 10x squared equals 0, and then 1 minus 3x equals 0.
Yes.
And in order to get rid of that squared, you'd oh my god, I can't remember. It's what the name of the v is called again right now.
But we're dividing both sides by 10, x squared equals 0, and then you square root both sides.
Square root.
Now when it's 0, it's just 0.
So then 0, it's 0. Okay.
So I mean that's it. That's the answer. How about this
So
one on the
fraction like that, I should divide it.
there's a number in
That
front?
always be that one of them should always be 0, correct?
No, that's
just
well,
check.
okay. In GCF, yes. GCF, it will always be a 0, I think. I think it'll probably almost always be 0 in your case. Not always, but
What I'm currently doing.
But yeah, but you just set each term equal to 0.
And then, okay, so then the minus 3x, 1 minus 3x equals 0, you'd add 1.
1 is positive already.
Subtract 1, I don't know.
Subtract 1.
And then minus 3x equals -1. Divide by -3. Then you get x minus 1. Oh, two negatives make a positive equals 1/3.
Yes.
Okay.
Okay, so let's try another one here.
No sense now.
Let's say after you factor it, you get 5x to the 4th, parentheses, 6 minus x squared. So we've already factored it. So we're just going to work on setting these equal to 0.
Okay, so 5x to the 4th equals 0. And then 6 minus x squared equals 0. And then 5x4 equals 0. So you have to divide by 5.
Okay.
And then that would make x4 equals 0, and then square root it all.
So this is new, but like I want you to see here that when it's just x equals 0, the only answer is 0. Like, yeah, it's the 4th root and that's great, but like a number times itself 4 times, the only way that's possible is if it's 0.
Mm-hmm.
So whenever you get like a single thing equal to 0, it's just 0.
Okay, yeah, that actually makes sense now that I think about it.
Good. Okay, now how about here on the right here? This one's a little bit tougher.
Okay, so you have to subtract 6.
Okay.
So then minus x squared equals -6, and then
you got to get rid of this negative first.
So divide by all by -1, so then x squared equals +6. And then
how many solutions should this have?
2.
So when you take the square root, what's that? When you square root both sides, what does it do in front of the number? What does it do in front? Plus or minus. Now, does this reduce? Does the square root of 6 reduce? Is it friendly?
No.
No. So here are your answers. 0, square root of 6, comma minus square root of 6.
All right. And then that's it.
Okay, so let's switch to square root property solving these. Okay, so we're completely shifting gears here.
Okay, sounds good.
All right, you went from first to second. Those are slightly easier than this. So we start out with one that was pretty basic. X minus 1 squared equals 16. To undo a square, how do you undo a square?
Square root.
Square root. Now on the right, it's plus or minus the square root of 16. On the left, the square root undoes the square. So that becomes x minus 1.
Yeah.
X minus 1 equals plus or minus 4.
And then x equals minus 4 plus 1.
So I like to add 1 and put it in front. So it's 1 plus or minus 4.
Uh-huh.
1 plus 4, 1 minus 4.
Oh, that's a good way to do it.
It should always go in front. If you've heard something different, try to get that out of your head. It should always go in front. If you put it over here on the right, you'll make some weird mistakes that aren't necessary. The number always goes in front.
Okay.
It's kind of like when we did these like 2x minus 3y equals 4. When you subtract 2x, you always put it in front of this. It's minus 2x plus 4. It's the same idea. You got to put it in front of the plus or minus.
So then that's the
final answer.
2 answers because it's squared.
Yes.
Okay.
Okay.
Thanks for telling me the like squared thing means 2 answers. That like
yes.
Finish on some of them.
That's the fundamental theorem of algebra, believe it or not. is the exponent tells you the number of solutions. All right, let's have you try one here. X plus 3 squared equals 36. Go ahead and give me, go ahead and work through this, please. Just like the last problem, and then we'll mix it up a little bit. We'll make it more difficult.
Okay, got it.
All right, so what's your final answers if you've got any?
-9 and 3.
Yeah, so you end up square rooting both sides. X plus 3 squared equals square root of 36 plus or minus. So x plus 3 equals plus or minus 6. You subtract 3 from both sides. It's minus 3 plus or minus 6, which is minus 3 plus 6, minus 3 minus 6, 3 and -9.
All right. And then should I just circle that as my final thing like on the test, or should I write like x equals 3 comma -9?
Okay. I mean, like the full answer is that it really depends on what your instructor wants. I mean, if there's a box here that said put your final answer in,
Just
do that. But what do I know?
Yeah.
I mean, it's really up to what your instructor wants when you're doing this. So, I mean, you can't go wrong with clarity. Like to me, this is really clear. If it's over here on the right, I mean, it looks unfinished. It's also correct.
Mm-hmm. Okay, I'll just make my own box, honestly, and write answer.
Yeah.
Okay, cool. And then, oh yeah, also last test I had when we were working on, I got a 4 on that.
Excellent.
Yeah, so these, I don't know why, like, I forgot to tell you, but all these tutor things help a lot because I've been getting like 3 5s and 4s on them. So
that's fantastic. I mean, you're doing all the work, and you should be really proud of yourself. I'm sure your parents are happy to hear that. Whatever you're doing, just keep doing it. And this applies to other classes you're taking. Like Yeah, it's math, but like whatever we're doing or whatever you're doing to prepare, that's how you're going to be successful in these other classes also.
All right, yeah. Thank you, Matthew. I wouldn't be able to do without you, but
All right, so let's take a look at some like a little bit more complicated problems. So for example, this is also a square root problem, square root property problem, but it doesn't necessarily look like it at first glance, maybe. But what did we say? How do you know that this is a square root property problem? We were pretty specific with it, and it has to do with this right here, or maybe these, or maybe this right here. Like those are your three guidelines. Like if there's just one x, it's a square root property problem.
um,
So like there's three things. There's just an x, it's in
mhm.
parentheses, and it's squared.
So there's an x, there's a parentheses, and it's squared.
Right. And there's
And
only one
then
x.
those are the main things I have to be looking for.
Yeah, I mean any one of them could lead you to that. All right. Now, the next thing here is you need to isolate absolute value x plus 3 squared. So if it's not clear, let's look at a related problem here. If I said, what is 2a minus 10 equals 0, and I asked you to solve for a, what would you do first? 2 times a minus 10 equals 0. What?
I'd figure out what 2 times what equals negative 10. So
Okay,
then,
but more generally, you would add 10 to both sides,
mhm.
right? And then
Oh, my bad.
you would divide by 2. So a equals 5.
Uh-huh.
Well, a is this x plus 3 squared.
Okay.
So in the previous problem we did, this is very important. Last two problems, the squared thing was already isolated. The squared thing was already isolated. But here in this new problem, it wasn't isolated.
mhm.
So
So
we isolate it. Like if it's not isolated, you make it isolated.
so then you have to add 10 and then
Yes.
divide the 2 into the 10, making it
Yes. Yes. What I'm saying is like to solve this problem, you first add 10, just like we did. And then you divide by 2.
plus 3 squared equals 5. And then with that, then you have to square root both of them, making it x plus 3 equals plus minus square root of 5.
Yes. Now this is where it's really important to when you subtract 3, or if it's if you're adding or subtracting as you move it over. But notice you got to put it in front. It's minus 3 plus or minus the square root of 5.
Mm-hmm. So put it in front.
Yes.
Okay. And then that would give you minus 3 plus 5, which equals 2, and minus
No.
3.
Whoa. Square root of 5 is square root of 5.
Right.
You just said minus 3 plus 5. And I don't know if you meant.
Oh, I meant like that. My bad.
Okay. And that's one.
So I have to write it with square root.
Yes, because there is no reduction to this.
So then, okay. So then, do I still write positive 2, or do I write square root of positive 2?
These are your final answers. And this is like what we were talking about the other day. These are like not friendly.
On the problem I did before, where it was 36 and then becomes 6, so it's like minus 9 and 3.
Yes, then it's okay.
Okay, and right, because it goes from 36 to 6. Okay.
Yeah.
Sorry.
Hey, can you give me just 30 seconds, please?
Yeah, of course.
All right, Zach, I'm back.
All right, sweet.
So like we had this discussion there, and it was actually a really good one. And it's really like this is where you've got to somehow be like, okay, square root of 4 is 2. That's great. Okay. But square root of 5 equals the square root of 5.
Mm-hmm.
You've got to train yourself to like be okay that it is the square root of 5. So if the answer is 3 minus the square root of 5, that means it's 3 minus the square root of 5.
Okay. 3 minus the square root of 5 minus the square
Yeah.
root of 5.
Like that's what it is. There's no way to change it in a way that will make it like better than what it currently is.
Okay, cool. So then write it in front, keep the square root if cannot be reduced.
Yes.
All right.
Okay. So next thing is we really need to talk about A and B now.
Uh-huh.
Uh,
Those are the ones that are a bit more confusing to me.
okay. Well, we're going to clarify that. So A and so that when you're there's two choices here. There's completing. Okay. There's factoring, guess and check, which isn't really a great answer, but or completing the square. Okay. What you're looking for is they're of this type: ax squared plus bx plus c equals 0.
Uh-huh.
They're both of this type. Okay, so like what does that look like? Well, it could be that it's x squared plus 4x plus 2 equals 0.
X squared plus 4x plus 2 equals 0. All right.
Yes. Okay. Now, to kind of help here, the factoring guess and check will most likely be an A that does not equal 1. Okay. And the completing the square will be one where the A does equal 1, most likely.
So complying square factoring. Okay, so
So let me snip in your two problems here and like illustrate that point again here. So this one, A does not equal 1, but the one that is in letter A, the leading term is that coefficient in front of x squared is 1. Do you see how the coefficient in front of x squared is 1 here? And then
yeah.
one on the left is 3.
Uh-huh.
Now that's not perfect, but that's kind of what you're looking for.
So then you can reduce it by oh, okay, sorry, I get that now. I don't know why I wasn't getting that. So then you have to make it if it's like x squared plus 4x plus 2, then you can divide the first two by x, right?
No, not for these. Not for these. This is a different method altogether. So we should choose either a factoring guess and check or completing the square path here to kind of learn. We did completing the square in a lesson a while back. So if you can go back and find the video,
It's oh god, sorry.
or the email, like I would recommend going through this one on the left, but it's up to you. We can. So is it okay if I start there, or do you want to do completing the square?
Yeah, let's start there.
Okay. So the idea with guess and check is that you don't know the answer, so you have to make an educated guess, and it comes from this right here. Do you see that this is 3x times x gets you that?
Yes.
So what you do is you write a term 3x and then x, and then what are the factors of 2?
1 and 2.
1 and 2. So you now have to figure out, does the 1 go here and the 2 go here, or is it 3x 2 and then a 1? And your check is FOIL.
Foil. And that's where you're going 3x times x, 3x times 2.
Yep, x times 1 and then 1 times 2. So you're a FOIL expert. FOIL these both, or FOIL the first one, see if it works, then FOIL the second one and see if, and let me know which one.
The first one is 3x squared plus 6x plus x plus 2. Oh, wait, I have to put the line in the middle. My bad.
Right. You gotta combine those. That's 7x. So that's no good. So it's probably the next one.
uh, where it's 3x squared plus 5x plus 2. And then this is where you have to put the line down the middle and solve both sides, right?
No, nope, we're not doing that.
Okay.
Well, yeah, we will, but not yet.
Okay.
So which one is right? Is it the first one or the second one here?
I think the second one.
So let's FOIL it. It's 3x squared plus 3x
2x plus
plus
2x plus 2.
plus 2. So that does get you back to the 5x. So now to answer your question, yes, you set each of these equal to 0. You set 3x plus 2 equal to 0 and x plus 1 equal to 0.
And then you have to subtract 2 and subtract 1. So then that's 3x minus equals negative 2. And
Yeah,
then
now you got to solve them. It could be many steps, could be not so many.
and then minus 1, x equals minus 1. That one's easy. And then make the square for them.
Yeah. What do you make the what?
The square answer, because you're done with it now, right?
Yeah, these are your answers.
Okay.
Okay, let's do another one here. Let's say it's 2x squared plus 11x plus 5 equals 0. And I'm telling you the type, like I'm telling you that it's a guess and check. So the first thing is you figure out, well, what are these? What are these? And it's 2x and x. So that's 2x, x. What are the factors of 5?
1 and 5.
Yes.
5, 1.
So figure out, is it plus 1 plus 5 or is it plus 5 plus 1?
Okay, wait. So in order to do this one, this is A, you have to have the 2x squared and then figure out what makes that up. So it's 2x and x. So you make the
Yes.
brackets. Then you look at the other number, which is 5, which can be made up by 1 and 5 or 5 and 1.
Right.
And then you have to solve it through that.
Yes. So it's guess and check because you don't know. And when you FOIL it, you do know. You figure out the right answer.
Okay, cool. I will start foiling it. Um, 2x. Okay, I think it's the first one.
Yeah, it is the first one. So you set it equal to 0. And then you set each of these equal to 0.
So set both of them to 0.
Yes, just like in the last problem. The last problem we set each of these equal to 0.
All right.
So here you're going to set each of them equal to 0. This one's out because it doesn't work. And then you solve it. You subtract 1 from both sides.
2x equals negative 1, divide by 2, x equals negative a half, x equals negative 5.
Yes. Okay, now, again, like these only get more difficult. Like I'm giving you kind of examples where I'm not trying to make this difficult on you, but you're ready to do one that's a little bit more challenging. And here is one of them. And the reason it's more challenging, 2x and x makes 2x squared. That's no big deal. But minus 9, well, minus 9 is either minus 1 times 9, 1 times minus 9.
I'll be right back in just a minute.
Sure.
Sorry. All right, sorry about that.
Yeah. So this one is more involved because yeah, 2x squared, it's 2x and x, but now it's a negative, and this introduces a lot of like complexities, but like it's either negative 1 times 9, 1 times negative 9, or 3 times negative 3.
Okay, so then when you have it like that, then it's
So
2x and x, and if you're making it into...
So it could be this, or you could flip it. It could be 2x plus 9, x minus 1,
or
2x plus 1, x minus 9.
So we're figuring out how that 9 and the 2
and the
make
1 and the yes. Well, all the 2 and the minus 9.
the 2 and the minus 9 make 3.
Yes.
Okay,
And
so
and then like there's one more. 2x plus 3, x minus 3, 2x minus 3, x plus 3. Now, like, I don't think you'll get one this complicated, but this literally is the guess and check. And there is a better method, but you haven't learned it yet in your class. Yeah. So the correct answer, though, I don't want to suspend your entire rest of your unit, I believe, is this one down here. All right, it's 2x squared plus 6x minus 3x minus 9, 2x squared plus 3x minus 9. That's what we're looking for here. So this is the right one. You set it equal to 0.
So then you have to make both of the, so 2x minus 3 equals 0 and x plus 3 equals 0.
Yes.
And then that would leave you with 2x equals positive 3, x equals 3 halves, and then x equals negative 3.
Yes. So let's do one more of this type that isn't nearly as difficult, but it does require you to do a little bit of guess and check here.
Okay, so then 5x and x. So then
but what about 12? 12 is 1 and 12.
2 and 6, 3 and 4.
Yeah, and that's it. So now, this is doable, but and so here's how you would actually do it. Like, you wouldn't actually write them all out. You would, and you tend, like, there's strategies, you tend to try the numbers that are closer together first. So if you go plus 3, well, let me not guess right the first time. Yeah. Let's say you go plus 4 plus 3. Okay. Well, I just did again. I'm sorry. That just did it. But, that gives you 15x. Go ahead.
When you have it like all this, how do you figure out like how to make the 5 and that other number work together in order to make 19?
It's the outer and the inner.
So I actually have to FOIL it in order to find out it makes 19.
Only the O and the I.
Okay. Oh, okay. All right. Awesome.
Only the O and the I. Yeah.
Okay. Thank you.
Let me see if I can go back and figure out where we did completing the square in our notes. Unless because that video.
I think it was, what was that? Like a month ago. I think I can scroll into my email and find that one.
Yeah, if you find that just matched up with the date and time on either the notes or go to the YouTube channel, look, search the date and time. But we did like enough examples that I think you'll get it. So hopefully this helps. We are unfortunately out of time for today, but thanks so much for scheduling. I'll send you the notes here shortly, and I'll see you next time.
All right. Thank you, Matthew.
Have a great night. Bye now.
You too. See ya.